Continuing our concept of electromagnetic radiation, I'm assuming that by now you have seen or been introduced to the fact that if you pass a white light through a prism, it will separate it into all of the visible light spectrum: violet, indigo, blue, green, yellow, orange, and red. And that's if you're passing a pure white source, a pure light source, white light. Now, if you do the same thing with a gas and heat it up, pass an electric current through it, or apply it to a flame, and you cause the light to go in a single direction, pass it through a single slit, and put it through a prism, you do not get Roy G. Biv. You end up with discrete lines or bands of continuous radiation that provide a specific emitting, or that can be used to identify a substance because they apply to very specific energy levels. So, rewind and reverse that. Let's talk about energy levels and electrons. You know from baby chem that electrons can be found around the nucleus in certain energy levels. What you might not have learned or might not remember from baby chem is that if you excite those electrons, if you piss them off, there are two ways you can piss them off. You can apply an electrical current to them, or you can light them on fire. Trust me, if you were lit on fire, you'd be pissed off too. This excites them, and it causes them to jump up an energy level. So they absorb energy, and they jump up an energy level. When they fall back down, they release that absorbed energy in the form of light. And when we did the flame test in baby chem, you saw that different metals produced a different color flame. Now, how many energy levels they jump up corresponds to how much further they have to fall back down. And that, in turn, will correspond to the spectrum, or the lines you can see when you split the light emitted by a gas when it has been excited. So emission is when an electron falls back into its ground state, because that's what we call it when it is in its normal orbit, or its normal orbital. Emission is when an electron goes from being excited back to its ground state. It releases a photon. When it absorbs some form of energy, it is called absorption. And the discrete lines that appear when you pass the light produced by an excited gas correspond to its energy levels. Niels Bohr, you know, the model guy that you've seen before, he connected this spectra with the ideas of Einstein and Planck, and said that the single electron of the hydrogen atom could occupy only certain energy states, meaning it was a stationary and set amount. Bohr also made the mother of all assumptions, and in your packet it's labeled as the mother of all assumptions. An electron in an atom is going to stay in its lowest energy state possible. Much like students will go to the easiest AP class they can find, electrons will stay in the lowest energy state possible, unless they are disturbed, meaning they are excited. And because chemistry demands that we confuse you somewhat, an electron with an energy level of 1, meaning it is the closest to the nucleus, is the most negative. And as you move out, the energy levels become closer and closer to 0. They become more positive. Not that their charges are positive, it's just the sign for their energy levels are going to be more and more positive, less negative than anything, the energy for any electron in the first state. So to move from the ground state, which is n equals 1, to n equals 2, an electron must absorb energy, and therefore the change in energy will be positive. To go from 2 to 1, the electron must lose energy. Emission is an emission, it emits energy, and therefore the change in energy will be negative. Also, it's all or nothing. You either have to go from being N1 to N2. You can't go from being N1 to being N1.5. There is no half energy level. So if an electron is going to get excited, it has to absorb enough energy to make it an entire energy level. It's like you're either excited or you're not excited. It's like being pregnant. You're either pregnant or you're not pregnant. Electrons are the same way. Now Bohr was able to determine a calculation to determine the amount of energy that was needed in order to go up or down an energy level. And don't worry about trying to memorize this. It's on a formula sheet, so you'll never see this in a multiple choice question. But its energy equals negative 2.178 times 10 to the negative 18 joules times Z represents the nuclear charge squared divided by the energy level squared. Nuclear charge is simply how many protons are there. So if you're talking about hydrogen, it's 1, helium 2, lithium 3. Energy level, are we talking about first energy level, second energy level, so on and so forth. And if you use these E's, you can calculate the change in energy necessary to go from ground state, where N is 1, to any energy level you need to go to by simply adding and subtracting them up. The hardest part about this is remembering that emission, you are losing energy. Absorption, you are gaining energy. So it's simply the sign you need to keep track of. Now Bohr's theory has two major holes in it. First off, it only works with elements with one electron, which would be hydrogen. And the one lonely electron does not orbit the nucleus in a fixed path, which we now know to be true. So this formula has some holes in it, but you are still responsible for it. Again, you, in extremely rare cases, will see this on a free response. The concept behind it is what you will be most likely tested on, and those are in multiple choice.